All right, so here's the 6-4 homework. I'm going to do the multiple choice first and then get to the graphs. So multiple choice number 2, they've given us the derivative, which is convenient, so we really don't have to do much work to come up with that. I can see my critical value. Notice that my critical value at 3 is a double root, so I'm expecting my sign not to change. I've tested values and come up with my sign pattern. Again, notice the sign did not change at 3. It did change at -1. It did change at 5. And because it went from negative to positive at x equals -5, I know we've got a minimum. Since it went from positive to negative at x equals -1, I know I have a maximum. And because there was negative to negative, no sign change at 3, I know it's stationary. So choice D. Multiple choice 3 is basically asking me for end behavior. I've got a negative lead coefficient. I've got a odd degree, so I know it will be up on the left, down on the right. Choice D. All right, so for the graphs, generally what I like to do is I start off by finding my zeros. Once I have my zeros, I find my critical values. I make my sign pattern of the derivative. That tells me where I have maxes and mins, and then I look for them. Right away off the bat, because I have a third degree polynomial, I might know my domain and range are both all real numbers. This is factorable by grouping, so I went ahead and factored my original function. I didn't continue showing that I had the difference of squares for the x squared minus 9, but I already knew that that would get me a 0 at plus or minus 3, 0, and 1, 0. Took my derivative. Derivative was not factorable, so I had to use my calculator to come up with my two critical values. Made my sign pattern of the derivative, and again, if I'm making a sign pattern of the derivative, everything I'm testing goes into the derivative. I can now see that I've got a maximum because my sign changed from positive to negative at -1.431. I know that I've got a minimum at 2.097 because my value changes from negative to positive. And because this is a third degree polynomial, no matter what, these are going to end up being relative maxes and relative mins. All right. Now, when I sketch my graphs, what I like to do is kind of go through and just label my key points. I know I've got a 0 at 1. I've got a 0 at 3. I've got a 0 at -3. If I look back up, my y-intercept was at 9. My relative maximum was at -1.431, and it was 16.901. So I've got a point up here to hit, and then I know my relative minimum was at 2.097. My relative minimum was -5.049. So this kind of gives me points to hit as I sketch my function. And again, these are just sketches. We're not looking for a fine-tuned graph. If we wanted that, we could just go ahead and use our calculator. And so that's why I do kind of a brushwork as I try and sketch my graph. All right, number 4. Fourth degree polynomial, so I know my range is going to be defined by either absolute maximum or absolute minimum. Because my lead coefficient is at +1, I know my range is going to start at an absolute minimum because my end behavior is going to be up and up. Domain is all real numbers in this chapter. I'm able to factor my original function to get my zeros, so I've got 4 zeros. For critical values, I found my derivative, factored my derivative, and came up with my critical values. Even though I'm not certain of what the value of root 5 over 2 is, I can start to look at my graph. I know that it's got to be more than 1. So as I try and test values, I can test things like 1 and -1. And again, because I'm looking at the sign pattern of the derivative, I'm only testing in the derivative. We're going to start to see that if we've got symmetry among our among our critical values, they tend to have the exact same y value. So if you go ahead and plug your x equals plus or minus root 5 over 2, you're going to end up with your absolute minimum of negative 2.25, and 0 gets us a relative max. And so again, when I sketch my graphs, I try and look at kind of my key values. I've got zeros at 1 and 2, at -1 and -2. And I'm just basically giving myself points to hit, okay? I've got my relative max at 0, 4. I know that my root 5 over 2 and my negative root 5 over 2 would fall in between 1 and 2 with that minimum at negative 2.25. So again, just giving myself points to hit, and I sketch my graph. And again, I'm not looking for a perfect graph. That's what a calculator or a computer is for. I'm looking for a good idea of what it would look like. Because nothing goes lower than negative 2.25, I know that negative 2.25 is going to be the beginning of my range, and it will go on to infinity. 6, again, third degree polynomial, so I already know my domain and range are all real numbers. Negative 4. So my end behavior is going to be up on the left, down on the right, and any maxes and mins I get are going to be relative. Now, this function was not factorable. I used my calculator to come up with my zeros. Even though they are integers, it doesn't mean we would have been expected to factor. Found my derivative. Derivative isn't factorable, so I used my calculator, my quadratic formula, or I graph it, or my polysolve. I make a sign pattern of my derivative, and again, if I'm making a sign pattern of the derivative, I'm plugging into the derivative to test values. Because my sign changes negative to positive, I know I've got a minimum at 0.131. Sign pattern changes positive to negative at 2.535, so I know I've got a maximum. And then if I plug into the original, I can get what those relative max and relative mins are. And so again, when I sketch, I'm just trying to give myself points to hit, just kind of guide myself through my graph. So I graph my zeros. My y-intercept was at -6. I had a minimum at 0.131, and it was -6.605, so it's just barely past that y-intercept. Sorry if you're hearing some odd noises, it's some work being done in my house. My relative maximum was in between 2.535, and it was very low, 0.879. And so now, again, I'm able to just sketch my graph, hitting these key points. Again, sorry for the noise. And I got a nice looking graph of my cubic function. All right. Much the same work now in number 11. I noticed that I didn't finish my range. So again, original function, not factorable. So I turned to my calculator to get my zeros. Critical values, found my derivative. Again, not factorable. So I turned to my calculator to get my critical values. And as I'm testing values, once again, if I'm making the sign pattern of f prime, I'm plugging into f prime. Now, because this is a fourth degree polynomial, I'm expecting to get an absolute minimum of some kind because I already know the end behavior is up and up. I'm not going to know what that minimum is until I take the time to plug in -4 and 2, the location where the sign changed negative to positive. And by chance, they happen to be symmetric values. I plug 1 in to find my relative max because my sign pattern changed from positive to negative, and I get my relative max as 17. And so once again, as I go to sketch my graph, I'm just using my zeros, my critical values, my maxes, my mins as a guide for my graph. So I've got my zeros. All right. I've got a, minimum at -4, so kind of right in between here, and it is -64. So I've got a point down here. I've got a minimum at 2, also down at -64. I've got a maximum when x equals -1, up at 17. And again, what I've done is just kind of given myself some points to guide my graph. And then again, because I've got an absolute minimum of negative 64, I know that that's going to be the beginning of my range for this function. Hopefully this helps. Again, if you have questions, please feel free to ask in class. This is where we're going to end chapter 6, and we'll start chapter 7 next week.